Hello, AP Stats. This is Mr. Kim, and I'm hoping you guys are enjoying your spring break thus far. I know that this is not ideal in terms of trying to learn something over the break, but I hope that you guys all realize how much work that it's cut out for us, and we have a lot to do. So this will be the part one video of the chapter 9 review, and let's just get started here. So for the vast majority of this, there is going to be a lot of type 1, type 2 error questions, a lot of hypothesis and how to state the null and the alternative and things like that. And several questions we did go over in the class. Let's start with number one here. So a university administrator in charge of computing facilities will close a computer lab if there's convincing evidence that the proportion of students at the university have access to a computer at home is greater than 0.6. So we're talking about the proportion. So we have to use the p-values, which means we can eliminate a and b right out of the way because that is a parameter in terms of it describes the mean, where p would represent the proportion. So is greater than 0.6. Well, that leaves me with only answer with C. Greater than proportion of 0.6. That should be your alternative. That should be in your alternative hypothesis. So there we go. Number two, the manager of a large hotel must decide whether to hire additional front desk staff. He has decided to hire more staff if there's evidence that the average time customers must wait in line before being assisted with check-in is greater than 3 minutes. So there is your null and there is your alternative. Which of the following could be a consequence of making type 2? Now, type 2 is when you fail to reject the null. But what happens is that the alternative hypothesis is actually true. So when you fail to reject the null, that means that you actually accept the null. You believe that there is actually about 3 minutes. And so you are going to, let's see, must wait in line, must be assisted is greater than 3 minutes. So you're deciding not to hire, right? You only hire more staff if it's greater than 3 minutes, but you don't. So we are actually going to eliminate C, D, and E, deciding not to hire additional staff. But when we say that the alternative hypothesis is actually the one that's true, the wait time is actually greater than 3 minutes is what we want to say. So that should be A for number two. Number three, the principal at a large high school will implement the proposed after-school tutoring program. If there's an evidence the proportion of students at the school who would take advantage of such program is greater than 0.1, well, we find out that the alternative hypothesis is greater than 0.1. We want to make sure that which of the following context is type 1 error. So type 1 error is when you reject the null. And then we believe that, or the actual true proportions or true mean, the parameters that you discussed in the null hypothesis actually becomes the one that's true. So when we reject the null, we believe that the only proportion of the students who's interested in this program is only about 0.1. And so that means that we are not going to implement. So we're actually going to eliminate all of this. It's really between B and D, not implementing the program, but when the proportion who would take advantage of the program is actually greater. So null hypothesis is actually, oh, I'm sorry. I just completely misread this. Sorry about this. All right. So when we reject the null, that means that we actually believe that the alternative hypothesis is true. So you actually do implement this program. My apologies there. So it's between A and C. You implement this program, but there isn't enough proportion of students who's interested. So that should be C for number three. Yeah, implementing the program and the proportion of students who would take advantage of the program is not greater than 0.1. Okay. All right. So number four, the marketing department of a national department store chain designs its advertising target to 18 to 24. All right. So skipping all of this, we have this right here. Suppose that the p-value in the test was 0.03. Which of the following correct interpretation of this p-value? Okay. So the p-value always represents when null is true. We need to start off with that statement. It's not a probability that the null hypothesis is true or false, is that when the null hypothesis is true, the proportion of the sample that you get, whether that's X amount out of the N, whatever the sample proportions that you get, the chance of that happening is the p-value. P-value, remember, if you notice, you need to find the z-score. Where do you find your z-score? You get it from the p-hat. So what that means is your p-value is directly impacted by your p-hat value, your sample proportions. And so depending on what type of sample proportions that you're going to get, your p-value is the one that actually is determined by it. And also vice versa, the p-value, you can determine it as to how often, what's the chance of the sample proportion happening when the null hypothesis is true. So when you read between C and D, when the null hypothesis is true, the probability of seeing the results as or more extreme than what was observed in the sample is 0.03. This is exact definition of what the p-value is. When hypothesis is false, we don't start off with that statement. We always assume that the null is true for any p-values that's out there. So of number 4, it should be C. Number 5, in a random sample of 200, 30 reported that they had logged into a magazine website. So we have this. P is the proportion of subscribers, blah, blah, blah. P-value is 0.001. So which of the following is a correct conclusion if alpha level is 0.01? So we know that the p-value is less than the alpha value. And so if the p-value is less than alpha, we reject the null, yes? So what does the null say? We say that the proportion of people who actually subscribers who download the recipes is 0.25, but we reject that idea. So we believe that there is a sufficient evidence to believe that the proportions of the subscribers who download this recipe is less. So there's a convincing evidence who download the recipe is during the last month is less than. So that is what B clearly says what I really want to say. There's convincing evidence that the proportion of subscribers who have downloaded the recipe during the last month is less than 0.25. It's like your second sentence of your conclusion portion. It's like you always start off with the words, there is a convincing evidence, blah, blah, blah. And so, yeah, that's basically what it's going to be. And number 5 is B. Number 6, which of the following affects the power of a test? The sample size, as it grows bigger, your power goes up. The significance level of the test goes up, then the power goes up. The size of the discrepancy between the actual value and the hypothesis value of the population characteristic. So that's called a parameter. So hypothesized value of a characteristic, it's actually talking about the value in the null, like what in the hypothesis, we state the null to be certain things. If the null and the parameter, whatever the value that's described in the parameter, if the size actually grows, then your power actually grows down. So you want to maybe have a value that's the smallest or actually closely related to the parameter value that's stated. So actually all of these simply affects the power of a test. So it's E. If you go back to your notes, this third bullet point, it's phrased a little bit differently from what the textbook definition has given you, but the value of the population characteristic, that's the fancy way of saying a parameter. So I think that should really just summarize the whole deal there. All right, number 7. So this is one of the easier ones. Like I told you before, if the sample size is increased, the power is increased. So assume the same sample size is used. We decrease the significance level, so the power decreases. Number 8 is A. So we have this is number 7, 8, and 9 are all dealing with power. So the sample size is used here. The significance test is used here. And this is talking about the parameter. This is the third bullet point. What's going to happen if we actually use these values for the measure of parameters? Which of the following will give me the smallest possible power? Okay, so in order to answer this question easily, the way that we always remember this is that if the null value that's determined by it, and if the alternative hypothesis value, if the discrepancy between these two values grow, then your power will also grow. That is what the third bullet point in the notes is talking about. So what that means is, let's say that the null declared here is at 100. If we want to put the power of the test to be as lowest as possible, we want to pick an alternative value for the mean in this particular example that is actually closest to the mean as possible, closest to the null value as possible, because as the discrepancy of those two values is down, then the power becomes the lowest. So the closest value here that you're going to get is 101 for this question. For which sample size and choice significance level will the power of a test to be greatest? Well, first of all, let's just take a look at these last three, because obviously the sample size, the greater the sample size, the power will go up. And then remember, the alpha level goes up, then the power also goes up. So it has to be D for number 10. Oh, I'm sorry. Number 10, number 10 should be C. I completely overlooked the fact that 0.1 is bigger than 0.05. That's my apologies there. Number 11, a psychologist runs a study and reports her results were statistically significant at 0.05. This result means which of the following? Okay. When we say statistically significant, I don't think I actually went over this, but this actually means that the alternative hypothesis is whatever that they're trying to prove is actually going to be true. In order to get that, we need to make sure that the null hypothesis is actually rejected if p-values is less than the alpha level here. So therefore, we want to say that the alternative hypothesis is going to happen, or it's statistically significant once we reject the null, p-value is less than, smaller than the alpha level of 0.05. Number 12, a type 1 error occurs. This is one of the easier ones. We are rejecting the null. However, we shouldn't have rejected it. So first, we want to say that h of 0 is rejected when it should not be rejected. So 12 is A. Oh, I keep on misreading this, guys. This is the null hypothesis, and C. It's so similar to each other. So number 12 should be C. A type 2 error occurs. Obviously, it's when the h of 0 is not rejected, when it should be rejected. So it's B for 13. Number 14, a graduate student at a wealthy university wanted to study, blah, blah, blah. Recent study said that the average student carries $31. So he sets out to see if the students at his campus actually have more money. So let's declare the alternative hypothesis as, not the proportion, but the mean of the money, average amount of money that the student carries around at any given time is more than $31. So the null hypothesis would be when the mu is actually equal to 31. Consequence of type 2 error in the study means that you failed to reject the null. But then the alternative hypothesis is actually true. So if you actually fail to reject the null, it means that you believe that there's enough evidence to believe that the student does not carry more than $31. It's going to be equal to or even going to be less than that. So this will lead to a wrong idea that the student on his campus did routinely. Okay, so reading all of this, first I want to figure out which one actually has the wrong idea that the student on his campus were like other campuses and only carry around $31 when they really carry more. So D sounds great. This would lead to the wrong idea students on campuses carry less than $31 on average when they actually carry. No, we failed to reject the null. So this is actually going to be true when in reality they actually carry more than $31. Campus carry more than to study amount to the recent study, the average student, so carries $31. So this will lead to a wrong idea, right? So a wrong idea, the students on this campus were like other campuses and only carried $31, in which we believe that the null hypothesis is true. But in reality, they actually do carry a lot more money there. Okay, 14 should be D. The prom committee is debating about the change in the location. So they must have at least 46%. All right, so proportion. So let's eliminate A and B. Those are talking about the sample. I mean, not the sample, the parameters for means. Preliminary survey of students showed that 25 out of 52 students would attend if the site changed. Guys, remember this has really nothing to do with stating the null and alternative hypothesis. It's always dealing with whatever they declare in the first place. Assuming they have a large enough sample to run a test, what would their null and alternate hypothesis be? So we are talking about having at least 46% means that it's got to be 46 or greater percentage. So we're not going to be talking about D here because that's a two-tailed either end, either greater or less than will do. That's not what we're talking about. E also the 0.48. The reason for this one, I guess they just put in there to throw you guys off. But these values, remember, they always must be the same whenever you're declaring the null and the alternative. So 15 should be C. Good. Number 16, a consumer group claims that more than 60%. So that means that alternative hypothesis here would be P is greater than 0.6. What would be an appropriate hypothesis for this group to study this? The null hypothesis is that P is equal to 0.6. So we're not talking about anything less or more. The alternative hypothesis is that less than, nope, less than or equal to, nope, it's going to be more than 60% of the teens are exceeding the limit. So 16 should be E. If the null hypothesis is not rejected, there's a strong statistical evidence that the null hypothesis is true. Now, I know some of you guys might be having questions on this, number 17. When I first read this, it also kind of confused me, but once I gave it a little thought about it, the way that this is phrased, it has to be stated in a little bit more geared towards the alternative hypothesis. So I will give you an example in relations to 16. So we want to find out a consumer group claims that more than 60% of the drivers driving after 10 p.m. are exceeding the speed limit. So we declare our alternative hypothesis as P greater than 0.6. Your null hypothesis is that P is equal to 0.6. Now, when we say that the null hypothesis is not rejected, we are actually taking this as our conclusion or whatever that we were claiming that to be. But this actually means that the proportions of the the teenagers driving after 10 p.m. is equal to 0.6. So strong statistical evidence that the null hypothesis is true. Well, the null hypothesis is stating that it's equal to 0.6. We're actually stating that, it is not greater than 0.6. That is how we want to read this null hypothesis. It's not that it's equal to 0.6, it's that it's not greater than 0.6, because what the other half of that story would be that this alternative hypothesis would state that the greater than 0.6 and proportions of this teenagers driving after 10 p.m. So to phrase it a little bit more appropriate to statistical setting, we need to say it like this, not the fact that the null hypothesis is true, because if that's true, then you're literally claiming that exactly 60% of the the teenagers are driving after 10 p.m. But in reality, it's actually less than 0.6 or equal to, but it has to be stated in a much more geared towards the alternative hypothesis. That's what I mean by that. Okay, so that's 17, so it's going to be false for this one. Okay, number 18, referring to the information above, the p-value of the test. Oh boy. Okay, so it seems like we have a simple random sample of 100. Suppose that only 4. So p hat is 0.04. Okay, so that is 2000. We should state that if we're going to do the plan portion. We have our alpha level here. Nope, we do not. So we want to just find out the p-value. Okay. So in order to do this quickly, I'm just going to use my calculator here up a little bit. And so I'm going to go here, algebra 2. And this is simply a one proportion z-test. So I'm going to go to 5. So p hat here that's declared is 0.1. The x is 4, and the sample size is 100. And if you actually state this, see this carefully, it says that the alternative hypothesis is p is less than 0.1. So it's less than p sub 0. Let's calculate. And so it seems like we have a z-score of -2, p-value of 0.0228. So the value of this, or the answer to this, should be C. Number 19, referring to the information above, which is the following assumption for inference about proportion using hypothesis is violated. So SRS is there, so that doesn't violate anything. And more than anything, it actually proves the condition for the planned portion. The population is at least 10 times as large as the sample. Yes, because it's over 2,000 potatoes. The confidence level is not stated. We don't need a confidence level when we're doing a significance test. Significance test and the confidence interval test is two different things. N is so large that both n p sub 0 and n minus 1 minus p sub 0 are 10 or more. So that actually is a great thing. That proves a large count. So there appears to be no violations. Number 20, a 90% confidence interval for the proportion of P. Okay, so we're going back to confidence interval, which is chapter 8 stuff. No problem. So we're just going to go here. And this seems like we have stats and tests. I think we have the Z interval test. But the only problem here is that it doesn't actually give me two sample Z tests. I think we have to just put in the Z test here. Right, one proportion interval, that's where it should be. Okay, so we have first 2 years of marriage follow up in these couples. She finds that 80 or couples are divorced out of 200, and the C level is 0.90. So we just have a sample with the X value and the confidence interval. So that's the only thing we can do. Now we can see that the actual p hat is 0.4, and that's where we should all start from. And it seems like the margin of error, if we just take a look, from 0.4, we moved about down 0.6, up 0.6. So we're looking at a value of D for this one, number 20. Number 21, in order to determine if having children within the first 2 years of marriage increases the divorce rate, we should, so if we're increasing the divorce rate, now we got to actually take a look at this. Because remember, guys, that's a p hat for 0.4. So anything with 0.4, I'm going to eliminate. We are actually looking at A or D here. So we are talking about increasing, so it should be D for 21. Okay, so I'm gonna stop the video here. I hope this helped to get you through the first half of this chapter 9 test. In the second half, I'll go over the rest of the questions as well as the free response. Thank you, guys. I'll see you in the next part.